great. Good afternoon, everyone. We had some very good discussions this morning and this early afternoon, and we heard a couple of times security. Yeah. Security. Yep. Security. Definitely yes. Security. Check the box. Security is very important. And a lot of other conversations about applications, customer experience, and things like that. So I think for the next 40 minutes, we're actually going to talk about what does the yeah of security mean for mobile at a intro level. So I don't expect to see a lot of Chief Info Security Officers in the room. So I don't think we're going to talk about threat vectors and current attacks from from foreign markets and things like that. We'll try to keep it at a high level. What should people be worrying about for security in mobile? And again, my name is Hans Reiskes. I work for a company called Sequent. Sequent is a trusted services provider. We help get card data and other types of payment data into secure elements in mobile phones. So we're very, very familiar with all the blood and guts and gore of putting card data in Google Wallet, what SoftCard does for putting card data in their secure elements, what Apple Pay does for putting their data in secure elements. Sprint in the United States has a separate program. So Sequent is one of those few companies in the world that actually messes around with that implementation technology. And we also support tokenization as another method now of bringing mobile payments to mobile phones. So that's just a brief background of where I come from. And my interest in this panel is very simple. Sequent believes that payment is just another feature of mobile applications. The 1.0 paradigm has been that there are special mobile apps that have unicorn powers that can talk, that know where the card data is and can make a mobile payment transactions like Google Wallet or right now we have Passbook, it now has magical capabilities. Okay, our belief is the only way we get to hundreds of millions of delighted consumers is to add payments to the apps they already love. I'll give you an example. We had a really good rollout of remote check deposit using mobile phones over the last 2 years. And we didn't roll it out with some special mobile app. We didn't have this special mobile app called Remote Check Deposit that you had to download from the App Store. It was added as a feature to your existing mobile banking app. You got the upgrade for your mobile banking app, and there was some coach marks on the screen that says, hey, look, we added something over here. You can deposit a check with your camera of your phone. Try it out sometime. And the adoption rate of mobile check deposit has been enormous. And the cost of acquisition of consumers doing that service has been very, very low. So that's a great paradigm for what Sequent believes how we need to have mobile payments adopted, which is we need to bring payments as a feature into the apps consumers already love. That's retail apps, that's transit apps, that's banking apps, there can be aggregation apps too. You may have a Mint wallet. You may have other apps that aggregate all your cards together so you can choose many different types of products at the same time. But to make that happen, obviously mobile security becomes a big factor. We're going to bring the most sensitive type of data into lots of mobile apps, and we need to figure out how to protect that. So to help us figure that part out, we have two experts on our panel, and I'm going to let them briefly introduce themselves. So first, we're going to have John St. Rose from Omlis. John, why don't you introduce yourself and just a couple minutes on your company.
Excellent. Hello, everyone. My name is John St. Rose. The company is Omlis, and we do protection, encryption. This is our main core business, specifically for the mobile payment services solution. So I'll just give you a kind of brief synopsis of us. But firstly, I'd like to apologize. I know Matt Banham was meant to be here, and an item of higher priority came up, so he had to remain in the UK. So apologies on his behalf. So I'm going to try my best to kind of answer and field as much questions as I possibly can later on. Okay, I'm just going to quickly run through where some of the barriers and so on that we see, and at some point, I don't know how much time I have.
It's about maybe 2 minutes or so on what is Omlis and what do you guys attack, and then get into the good stuff.
So for the best part, mobile adoption is being hindered simply because there is no trust. We do not believe and trust in the current solution that we have now. So we are saying that I'm going to just cite a couple little statistics for you guys. In a survey in 2014, there was 46% of respondents, 46% saying that they do not trust, they do not believe that their payments will be secure enough for them to ever use their mobile phones. So that means that we've lost a big part of that market, even before we've started. So Omnis has decided to take a new approach, and we have created what we call a high-integrity encryption solution that will now sit in the back of almost any application that is out there, and we will guarantee, okay, maybe a too strong a word, for the best part, we are saying that you have got the best possibility of getting that payment from your mobile phone to your financial institution, to your bank, or wherever it is, securely, because we are using a high-integrity coding language for our encryption.
Perfect, perfect. All right, next I want to introduce Vince Arneja from ArcSyn. Vince?
Okay, thank you. So my name is Vince. I'm with ArcSyn. You probably haven't heard of ArcSyn. ArcSyn is focused on application-level security, if you will. ArcSyn's been around for about 12 years. We have morphed over the years and evolved to cover a lot of different computing platforms. We started out working for the DoD, which then evolved over to desktop, to server, to embedded, and really about 4 years ago to mobile. So I'll give you an example of where ArcSyn comes into play. If you are a Netflix user and you have an iOS phone, you're using our technology because it's actually baked into the Netflix app. If your kids play Star Wars on a Windows machine, our technology is baked into that as well. So it gives you a sense of the footprint that ArcSyn has. We're sort of the security component inside of a lot of sensitive use cases. Clearly, mobile payments is a sensitive use case. And so our technology, basically what it does is it allows for the builder of the application, in this case the mobile payment, mobile wallet application, to basically protect the application itself. So we are effectively providing in-app protection. There's a lot of terms out there that speak to what we do. Obfuscation is a term that's related to what we do. Integrity checks within the application is something that we do. But really, if you think about from a security perspective, there's been man-in-the-middle, man-in-the-browser type attacks for years. That's very common terminology in the security world. We're focused on attacks that are for man in the application, in the app itself. And that's really what we're focused on.
Beautiful, beautiful. Okay, so to help bootstrap into this conversation, this is especially this late in the afternoon. If you don't have enough caffeine, and we're about to talk about security, I can sense sort of the the energy kind of waning a little bit. So we'll try to keep it as entertaining as possible to get you to the last panel of the day after us. So one of the things that Sequent works with a lot of banks and some merchants, and a lot of the banks have been focusing on sort of their 1.0 applications. There was a similar paradigm with the internet where everybody had to get their first version of the website up. It was informational. It was, hey, if you wanted to know where our locations were or what time our store was open, things like that. The first version of the website, it was mostly informational. I feel like mobile apps have also gotten the brands to that position today, where everybody has their first mobile app out there. They've got a one-way informational communication going, and now they're looking sort of to add in some of the more exciting, sexy kind of functionality. Mm-hmm. Can you guys each talk just briefly about should we be worried about security on informational-only apps, their 1.0 apps, and when should brands start worrying about security as they add more features? Is there a special feature? I mean, obviously payments, but is there other features that once you add that to your app, you need to start thinking more heavily about security? John, you want to go first?
Yeah, well, I think as we all sit here, we don't have to wait to actually think about security. Security should almost be a priority. There's a lot of other things, a lot of different complex bits of the whole ecosystem, but security is quite prevalent and it needs to be thought of. There's no level. I wouldn't want to say, let's wait till we get to a certain point before we think of security. Security should just be that. I'll give you an example. On my phone, if I download an application, I don't want to think if I have to upgrade is when I'm going to be secure. I want to be secure as and when. So we think about this from the retailer's point of view. the application that you have or that you're going to use, you want to think about if it ever gets compromised, what effect is that going to have on your brand? Because once it happens once, that's all that's necessary for doubt to be created. So you have to think about it pretty much all the time and keep on top of it. Yeah, you don't want to have to fix a problem after you've already been breached, and then have to use the marketing to then kind of get yourself back.
I feel like you're my dentist. You know, he always tells me floss, floss, floss.
Right.
You know, otherwise someday
Yep,
you're going to
yep.
come in here and it's going to be painful.
That's exactly it.
Uh-huh. Well, what do you think, Vince?
Well, so but my view is a little different, so I'm going to disagree with John. I mean, I think pragmatically speaking, that's unrealistic. I think security does not pertain to informational apps or informational anything. Transactional applications that are more and more transactional, dealing with sensitive information, that's really where the focus needs to go for security. Our emphasis is app-level security, which unfortunately gets put at the bottom of the barrel when it comes to security in general, right? Network security, endpoint security, those kinds of capabilities take precedence just because of the server-centric nature of our architectures these days. But with these second-generation applications and third-generation applications that Hans is referring to, these applications are client-rich. They're richer on what's on your phone. There's more code that's running on your phone than ever before. And as those applications evolve, and even though it's not mobile payment, Facebook is a great example. They had a browser-centric capability. They had a HTML5 app. Well, it pretty much sucked, to use @Pay's words. And so they had to go to a native app, which basically required more security to be built in. And so that's the transition that they made. I think we're seeing that from a lot of the financials ourselves, is as they're making that transition to a native app, to an app that's more transactional in nature, whether it be remote deposit capture or whether it be peer-to-peer payment or remote wallet or proximity wallet, they're thinking about these things. And sometimes when they're not thinking about it because they don't have the expertise, they bring in a pen testing firm that does the thinking for them and gives them tangible results, and then they have to act upon those.
Got it. In fact, it reminds me, the Google Wallet team is about 8 miles from our building, and one of their requirements in the Google Wallet, the original version 1.0, was you had to be able to make a payment if you didn't have any internet connectivity, right? Obviously, you're in a store, you have bad internet connectivity, you're in a, in a subway, whatever. You can't trust the cellular network's going to be available, so you have to be able to make a payment. You have to be able to make a payment without internet connectivity. So where do they validate the password for the wallet? See, if you're not connected to the back end, you have to store the password on the device somewhere so that locally you can check the password. Well, they stored it in where Android stores all secure things, which is they have a certificate storage mechanism called Delvik, and they stored the password in there. Well, it's very easy to break Android's existing level security. And that's when you read something about, oh, Google Wallet was hacked, blah, 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 something about the password. That's exactly what happened. They had a use case that said you had to be able to make a payment without having internet connectivity. They had to store the password for the wallet on device somewhere. They stored it as securely as they could, right. But ultimately Android is unsecure, and so hackers were able to get underneath it and hack the password. So this is not, Google is, they'll remind, if you haven't worked with Google at all, they'll remind you they're the smartest people in the world. Okay, so even the smartest people in the whole world can make obvious mistakes trying to get to consumer happiness. So maybe you guys can talk briefly. What does the operating systems provide us? I mean, iOS, Android, Windows. There's still BlackBerry OS out there somewhere. Canadians. What are they providing to help us? Is there anything native there, or is the burden on the application owner to take 100% ownership of security?
You want to take that one, Vince?
Yeah, sure. So it depends on the operating system. Obviously, iOS is a walled garden, so there are some inherent limitations as to what anybody can do, which is effectively providing some semblance of security. Android is basically a who's who of different flavors of Android, forked versions of Android. And so we're seeing a lot more customers that are coming to us concerned about Android security specifically, because when they do their pen test, they see the results within those applications that are Android-based. And HCE is another great example. HCE is, of course, Android-centric, right? That's what Google put out with KitKat back in, I guess, almost a year ago now in 4.4. And that's an example of where the Google Wallet scenario resurfaces, because you don't have a hardware secure element anymore. You have to store information, secrets, if you will, locally in order to execute that transaction in offline mode, which is what Hans is referring to. And so we're seeing a lot of customers come to us with that specific need. Just in fact, earlier today, I was on a call with a customer where they're architecting their solution, and they're looking for trusted advisors to aid them in that process. So BlackBerry 10, I can't tell you anything about. We don't even support it because from my perspective, it's got no footprint at all. Windows Phone, we are seeing some genuine adoption in the UK, specifically in the Europe area, obviously because of Nokia and Microsoft. I can't speak to much of the inherent security capabilities there, but I will tell you 95% of our mobile business is Android and iOS. But there are distinctions between Android, and just to go one minute further, if you're coding an application in Android, you can code it in Java, which he referred to Dalvik as being the runtime environment, or you can code it in native. So when you talk to a security consultancy or security experts, they'll tell you if you are doing anything around security controls, which obviously a lot of these applications have, root detection, authentication, those kinds of mechanisms, you have to do that in native code. You cannot do that in Java just because it's so easily decompiled and bypassed. And so those are the kind of security decisions our customers are struggling with making, and then testing, and then going through that iterative process with security.
Got it. So
I'd just like to add, on what Vince was saying. With this is where somebody like Omlis comes in. We have the similar type HCE, but we didn't do it in the native language. We actually decided to go into use Ada Spark technology, which is a highly mathematically provenly secure coding language. So this kind of eliminates or takes us away from the native or Java. We no longer, and it then also means that we can actually become agnostic. You don't have to have an Apple-specific coding language. We don't have to have an Android-specific. It will sit on any mobile phone, any model, any make. So just answer your question. It does really depend on how much security you're actually trying to put onto that phone and what you then use. If it's something where, if it's just, as you said, it's just information we're trying to store, then yes, we can probably use something a little less. But if we go in high end, we then go to the big boys.
makes sense. So now that we're kind of sort of freaking people out just a little bit, so how does this work? Okay, nobody in this room has ever thought about what to do about security, right? Let's just make that assumption. Yeah. So then they all have mobile apps. So what's the first step to start caring about the mobile side security? Is it hire a lab and have them do penetration testing on your app and basically fail the test before you can pass the test kind of situation? Is that how you get started to figure out what you need to do for mobile security?
Well, I mean, from my experience, and I've been in security now 13 years, and IT almost 20, you got to start with a secure architecture. Without that, you're basically wasting your time. So that's number one, and that's where a lot of the internal expertise comes into play. And obviously there's consultancies out there as well. Secondly is doing basic things. So focusing on the app level, Hans mentioned the web and 1.0, 10 plus years ago. There's been a lot of evolution on the web as it relates to security over the years, but mobile security in general is where web security was in 2004. I mean, it is very early. We talk about mobile payments being in the bottom of the first inning. Mobile security, honestly, is just getting in the batter's box. It's just starting. It's that early in the space in general. But as far as basic things that you can do things like static code analysis. You can analyze your code, putting it through an automated tool, and it'll tell you where your code is vulnerable for certain types of attacks. That's easy. You can do that in 5 minutes these days. Yeah. Obfuscating your code so that people just can't download your application and understand the ins and outs of it. That's also a very basic step these particular days. And so there's other things you could do that are more advanced, but from my perspective and some of the experts that we deal with, those are some of the things that you have to do if you're targeting a consumer-centric app. Arguably, if you're doing a B2E app or if it's an informational app, you can get by without some of those controls in place, but you have to at least do those basic controls.
I think even more basic is just get a reference. Every application has to be verified. Start there. See where we're going to go. Has it passed the verification process? That's the very first place I would start for any application. and then we can move on to Vince's ideas. Yeah.
Yeah, I think actually I've unfortunately been through a lot of information security audits with banks, and those are extremely painful, long and drawn-out meetings where they're talking about different threats around the world and where they're seeing an attack on mobile. And to your point, mobile is worse. It's much more difficult because it has the broad reach of internet connectivity, but the IT department that's protecting your mobile device is you. Right? The internet has IT departments, right, protecting against all the threats that are attacking the back-end infrastructure. Right now, the IT department is the consumers. You know, if they download an app, they download the wrong app, they do the wrong things with their phones, they're making themselves vulnerable without even understanding that that's what's going on. Absolutely. So let's switch. So we talked about some of the basics. What are some of the more advanced techniques for security? I mean, if, for example, Sequent wants people to add mobile payments to all apps, it's like HCE tokenization, that means putting credit card, card data, track 1, track 2, or other types of more sensitive payment card data in phone memory, right? I mean, that would be like the third rail of all chief information security officers at a bank. You say the word, card data and phone memory, it's an automatic stop everything. Right. So now that's what tokenization means. We're going to actually do that. So if we're going to do something as crazy as that, what kind of advanced security do we need to actually make that work?
Well, okay, sure. I'll just give you what I know, and this is obviously this is it's firstly you want to go for a particular security that is designed for the mobile phone. A lot of the infrastructure that is currently out there is kind of being shoehorned into the mobile, rather than it being specifically for the mobile. So in this case, I would say we want to develop, Omlis has developed and designed and tested the first high-integrity ADASPARC technology. This is something which is mostly used in security-critical situations, military security, airport security, air traffic control, air traffic control, and so on. ADASPARC is mathematically proven. Okay, it uses theorem provers, and this application, that just basically means that there is no possible side channel attacks on there. Usually, as we were talking about earlier, with the Android, they were able to go underneath. This, because it's mathematically proven, it kind of closes itself off. So there is no place for it to actually, for a side channel attack. Another, obviously, improvement of this is the fact that we are now looking for more amorphic keys to be created. Yeah, you want to be able to encrypt the transaction. The encryption needs to be created at the point of the transaction, and once that key is used, it's destroyed. It's no longer. We create and then another one. So we go for key cycling, authentication token cycling. These are the kind of advances we need to have in order to keep ourselves secure, keep our payments secure. Let's have a look. As I was saying, with this Omlis solution, it actually obviously becomes standardized across all platforms. So whether it be iOS, Android, it really doesn't matter the handset. Once an Omlis-enabled phone, it doesn't actually mean it. Sorry. Once you've downloaded the Omlis application, it doesn't matter the phone. It can be a 2G phone. So we're going right back to Apple III. Right up to the 6, it really doesn't matter. They're as secure as each other. So we want that level of security on your phone. So we're talking about really going up on the security side.
So as far as advanced protection techniques, there's a bunch of videos on our website that if you go to, you can get a sense of the kind of advanced techniques that are being used out there. There are frameworks like Cydia Substrate. This is basically a tool that allows for you to patch into an iOS or Android application. The need for secure crypto, of course, is critical, especially if you're talking about a use case that's HCE-based. Dynamic protections, being able to protect and detect what's happening in the environment around you. At the end of the day, the way that you have to look at this is that you can't put trust in the platform, you can't put trust in any container, you can't put trust in the cloud. You have to put trust in the application itself, because that's the only thing in a B2C type of scenario that you control. And so putting more trust in the application requires for you to have visibility and protection techniques implemented to the environment around the application itself. That could be other applications, which is where attacks like Swizzling comes into play, or to the environment and the device itself, which is where things like jailbreak and root matter in order to know if the application is running in those kinds of compromised environments. So there's a lot for you to do from an advanced security perspective, but from my vantage point, 0.1% of the people should even be thinking about advanced at this particular point. The other 99.9 should be thinking about the basics. We've actually done a lot of analysis of apps in the app stores, banking type applications, and I think the numbers we had last time, which was earlier this year, 60% of iOS apps or banking applications are completely unprotected. 95% of Android apps are completely unprotected. And so that just goes to show you, you as a consumer are downloading these apps, putting your credentials in, trying to do transactions. Who knows what kind of, especially on Android, what's happened to that application? Has it been repackaged, republished? A lot of those kinds of concerns are things that are mounting, if you will.
And the consumer is still the IT department that's supposed to be catching those things. So
Absolutely.
that makes it even more painful. So why don't we open this up for some questions? If you don't feel like yelling, you can tweet me your question at my handle is NFC Guy. So if you're not a yeller, you can go ahead and send it to me there, and I'll read it from my Twitter handle. But go ahead. Why don't you start right there? They sold you so hard, you should be worried, right?
Well, if you go back 3 years ago, you probably saw the same press release for Google Wallet. And you just heard about Hans's example there. So at the end of the day, there's going to be holes in everything, right? It's just a matter of how many holes are they proactively patching as they come out with this capability. Now, from everything I've read about Apple Pay, it seems pretty damn secure. From a hardware perspective, from a software perspective, they've taken a lot of the lessons learned over the last 4 or 5 years and taken those into account. And if you realize, if you watched the kickoff at WWDC, when they got up there, they talked about security. They didn't talk about the features. Sure, they showed a nice video of how easy it is to pay, but they emphasized about 6 or 7 bullets on security on that presentation. So they realized how important security is for Apple Pay to really succeed, and they took that right at the first minute. So personally, I'm pretty pleased with what I've read about Apple Pay, but I'm still waiting on my iPhone 6. So next time we get together, I can give you more details.
That's exactly what I was about to say. Just to add to it, it's okay with all the security, but you must have a phone. You must have an Apple 6 phone. What happens? I've got both, but I've got a 4 here. What happens to this one? I want to use it.
Well, get an Apple, get the watch.
Get the watch.
It has a secure element inside.
That means I have to spend more money.
Yes.
I don't want to.
That's the Apple model. Haven't you heard?
I don't
Buy expensive phones. You haven't gotten that yet? Apple's coming to the UK. Don't worry, it's coming. Okay. Yeah, and I can tell you from my knowledge of the Apple Pay solution, I would say that Apple Pay has no payments innovation in it. It is old school mobile payments circa 2007, okay? I mean, it does my little heart pitter-pattered when I got all the details of the implementation. It was like seeing your little child has grown up into a teenager and moved out of the house, but still remembers everything you taught him, okay? So in general, the Apple Pay approach has no payment innovation. They use some very sexy words like tokenization, but the implementation is not nearly as sexy as your mind would go. Think extremely boring, okay? It's still very secure. I think the most innovative thing they did is that they're using the character recognition to capture the card number off the card, right? Which previously MasterCard and Visa had prevented mobile payment solutions from doing. We've been trying to do that for a long time. MasterCard and Visa said you can't take pictures of cards. So Apple convinced MasterCard and Visa that this would be a better consumer experience. But that's about as far as payments innovations goes for Apple Pay. Everything after that is very, very boring, and that's ultimately very, very good from a security perspective. So, more questions. More uncomfortable Apple questions?
It's a good panel.
Yeah.
We've obviously answered everything.
Let me see if I just check Twitter. Did anyone send a tweet? Nope. So, all right, with that, I want to say thank you to please thank my panel here for a very interesting conversation on security. Thank you.